Alright, ladies and gents, Calc BC. Let's go. 3.7. Optimization is the last section, Unit 3. Before you do some more AP style questions, there's also going to be a test from Units 1, 2, and 3 after this. That will be in the AP classroom. I've already signed you up. Just go in there, find assignments, and then it's in there. It's a long assignment, and that doesn't mean you got to do it all. It's in there just to do enough problems or work on problems, okay? Don't worry about doing it all. It's like 100 and something questions. Don't do it all. That'd be stupid too. Okay, let's go through some optimization. So we're applying some minimum and maximum problems. Again, this is not that big of a section on the AP exam, so why do we do it? Well, because it's calculus, and you're in Calc BC. You're in Calc 2 right now, so you know it'd be nice to kind of do some basic level of calculus. And so let's go and determine what we got to do here. So the primary formula is an initial formula that you're trying to optimize. A secondary equation might be needed if this formula here is not in a single variable. So for instance, if I have V is equal to LWH, like that's the formula for a rectangular prism, right? If LW are the same, like now it's like a square prism, like the base is a square, then I can have like L squared H. But if H is not the same size as L, then I need to find another equation to use, and we probably would go to like surface area or something, right? And we got to make sure if one equation has like the V equals one variable, great. But if it's got two variables, then we're screwed and we got to figure something out. Okay? Great. That was awesome. Awesome sauce. Awesome sauce. Okay. So example 1 there, manufacturer wants to design an open box, so it does not close on the bottom or on the top. Anyway, having a square base and a surface area of 108 square inches. What dimensions will produce the box with maximum volume? So what I'm going to do is I'm going to draw a box because I'm awesome sauce. I'm pretty awesome, but I don't know how I want to draw this. So we're going to go like this. I don't know if I got to do this. And then that goes like that. And then this goes like this. Oh no, this is in front. I don't know how to draw these boxes, man. I'm just going to draw like this. I was going to draw with dotted lines to show you like what's behind and what's in front, but I kind of lost my jam. Okay, so there we go there. So this is X, and this is H. So because it's got a square base, right, so this is the base is a square down here. Sides are the same, right, X and X. So we can say that the volume is equal to X squared times H. Great, we have a formula, but the H is not the same as X. So we need to find H, right? So what we're going to do is we're going to take another formula that we can easily find there, and we're going to say, okay, well, it's surface area. Well, because actually it says surface area right there, and so, and because we have volume, we're probably going to use both formulas, right? So the surface area of this is going to be X squared, because the top is open, right? So the bottom is the only one with X squared, plus 4XH. All right, so then these other, I don't know if I can use a different color or not. I don't know if how do I do that? I don't, that's fine. The sides are what the 4XH is. The base is the X squared, and the top is open, so we don't need to find that one. And so then we know this is 108, right, equals X squared plus 4XH. And I want to solve for H, because then once I solve for H, I'm able to plug that into the volume formula, and then everything is in terms of X, and then I can go ahead and solve it. So I get 108 minus X squared, and once I do that, I get over 4X is equal to H. So I'm going to take all this garbage here, I'm going to plug it into there, and then I'm just going to rewrite it. So X squared, actually X squared times that, so it's just going to be X, and then there's going to be no X on the bottom there. So it's X times 108 minus X squared over 4. Okay, I'm going to distribute that because it's easier to take the derivative of that when I do that. So I get 108x minus x to the third over 4, which is equal to v, right? And so now I have an equation with v is equal to one variable, x, and now I want to then take the derivative of it. I want to optimize that formula. And so when I do that, I get v prime or dv dt. It's up to you, whatever you want to do. I'm sorry, it's not DVD. It's DVDX, okay, with respect to X. Because we're not actually, it's not related rate right now. It's optimization. So equals, this is going to be 1/4 times 108 minus 3x squared. And so then I can solve, why do I want to solve this? Well, okay, so V prime in this case, right, it goes to 0. So technically our volume is a constant. So it goes to 0. So now I want to solve for x. So let's do this. Let's do this. We get 0 equals actually, I'm going to get rid of the 1/4. I'm going to multiply the 0 by 1/4. So technically that 1/4 is now gone. Okay, hopefully you understand what I just did there. Equals now 108 minus 3x squared. I'm going to bring over the 3x squared equals 108. I'm going to divide by that 3. X squared is equal to 36. X equals plus or minus 6, but we know it can't be negative, so it's got to be positive 6. And then, therefore, the question then says what dimensions will produce the box with maximum volume. So I need to find the h. So I know I have x is 6, x is 6. So that's my base. But what's my h? So I got to plug it in, right? So this is going to be 36. This is 24. So I get 108. Oops, that's not 108. That's 180. I get 108 equals 36 plus 24h. Bring this over. That is now 72 equals 24h, and h is equal to 3, right? So h is equal to 3, and x is 6. So the dimensions would be like 6 times 6 times 3, or 6 by 6 by 3. Okay, there we go. And make sure you have units, I guess, in there. Does it tell you units? Yes, it does. Inches. So it'll be 6 inches by 6 inches by 3 inches. Okay, there you go for the first example. Let's go on to the second one. All right, finding minimum area. I know in B, C, I'm kidding. In A, B, we didn't like this kind of question because we always got confused. We weren't sure as to how we were doing it. So a rectangular page is to contain 24 square inches of print. So if I have a rectangular page, then we have our print, which we know is 24. Then what? We know the margins at the top and bottom are 1.5. So let's say here is 1.5, here is 1.5, and then the margins to the left and right are 1. So this is 1, and then this is also 1. Okay, what should the dimensions be of the page so we get the least amount of paper to be used? So we know our two formulas. Well, maybe we don't. We'll see. We know one formula is at least the area is equal to x times y, or length times width. You can use whatever you want. I'm just going to use x and y. It's not a big deal. We know the area is 24, right? So equals x times y. Okay. And so then, what do we know? Well, this is the area here of the print, right? What is the area of the actual page? Well, the area of the page is equal to x. We'll say x is lengthwise, like going this way, side to side. So x is actually x plus 2, right? Because the x technically is this piece here, but now we got to add the 1 for this side and the 1 for that side. So that's where we get x plus 2. And then top to bottom, it's now y plus 3. Okay? So now this is our page area. All right? Well, that's all fine and dandy. But now I have two equations, and this is what I ultimately want to solve. So I'm going to take the area of the little page, of the print, and I'm going to solve for one of the variables. And I'm going to solve for x, right? It doesn't really matter what you solve for, but I'm going to solve for x. So 24 over y. I'm going to plug that in to here. So I get a is equal to, and then I get 24 over y plus 2 times y plus 3. And I'm going to multiply that out because I can. So I get 24, because I'm going to FOIL it basically, plus 72 over y, plus 2y plus 6, which is equal to the area. And now because I have the area formula in one variable, which is just y, I am now able to maximize, or minimize in this case, that formula, so I can take the derivative. So I get a prime equals 24 goes away. This is really 72y to the negative 1, right? So that's negative 72 over y squared. If you can't remember why I do that, then we need to go back and review quotient rule or derivatives in that case at all. Plus 2, okay? So, that's pretty much it. I can't do anything there. But then I realize that a prime really is just going to 0, okay? And so now I want to solve for y. So when I do that, I get negative 2. I brought the 2 over, okay, equals negative 72y squared. But this y squared is going to go over here, and so I'm going to delete the y squared on the other side. I divide by that negative 2, so I get y squared equals 36, and so y equals positive 6, okay? Then what do I want to do? Well, I want to plug that into my x value right there. I want to find the x. So 24 over 6 is 4. Okay, so I get a 4 by 6. Well, 4 by 6 is actually in here. Okay, that's the area for the print, right? But then it says find the least amount of paper. Well, paper's over here, so I got to plug those values in. So 4 plus 2 is 6, and then 6 plus 3 is 9. So this is a 6-inch by 9-inch piece of paper. That's the smallest paper that could have those requirements for whatever this is, newspaper or whatever it is. Okay? All right. Cool beans. Love doing optimization stuff here. All right. A farmer. Hopefully he's a pig farmer. Farmer has 100 yards of fencing to form 2 identical rectangular pens and a third pen that is twice as long as the other 2 pens, as shown in that diagram. All 3 pens have the same width, x. Which value of y produces the maximum total fenced area? Alright, so what do I need? Well, I need a couple different things. So I have one area here. I want to find the area of the full, I don't know, the full box, you want to call it that, okay? So what I'm going to do is, okay, the area of the full box is really 2x, x plus x is 2x, and y plus y is 2y, right? So it's really 2x times 2y, which is 4xy, okay? So this is the area of the full pen, all right? Then, what do I need? Well, I can't really find, like, the other areas aren't going to really do much. They aren't going to really do too much stuff, so I'm going to have to find the perimeter, okay? We're always going to probably want to deal with perimeter because, again, this is if he's got 100 yards of fencing, well, that's going to go around the pens, right? And all that other dryos, the awesome dryos. And so I'm going to probably, have to find perimeter. So let's do that right now. So perimeter, we got to know is y plus x plus x plus y plus y plus x plus x. So we have 4 x's and 4 y's. I'm just kidding. We have... Oh, I got to include everything on the inside. Dude, not just the outside of the figure. Okay, so I actually have a y here, here. I got a y here, here. I got a y here and here. So I actually have 6 y's. 6 y's. I have an x here and here. I have another x here and here. So plus 5x. Okay, so that's how we get that. We know we have 100 yards of fencing, so that's going to be the perimeter is equal to 6y plus 5x. It doesn't really how you do this, doesn't matter how you do it, but I'm going to solve for x because 100 divided by 5 becomes 20 instead of 100 divided by 6 becomes 16.6 repeated, and I don't want to deal with fractions right now. Well, I'm going to deal with fractions, but not like big fractions like that. So when I solve for x, I get x is equal to 100 over 5 minus 6y over 5, so that's 20 minus 6y over 5, and that's what x is equal to. So then I'm going to take this value here, because that's the perimeter. I solved for the variable that I was choosing to. I'm going to plug it into the formula that I want, my primary formula, and then I'm going to take the derivative after I plug that in. So I get the area is equal to 4 times 20 minus 6y over 5 times y. Okay, so I'm going to kind of multiply all that garbage out. So it's going to be 80 minus 24y over 5, and all of that is still times y, and so then it's really going to be 80y minus 24y squared over 5. So that's what the area is equal to. All right, now let's maximize it, okay? Or well, yeah, let's maximize it, I guess. So let's find the derivative, okay? So I get a prime, boom, is equal to 80 minus, and then I'm going to take the derivative, so that's now 48y over 5. 48, oops, y over 5. And then we know the area goes to 0, okay? So now I can solve for y. So I'm going to kind of do some like simple kind of math here. And so I'm going to bring over that 80, which makes it negative. I'm going to multiply by 5, which makes it negative 400, right? So it's negative 400 is equal to negative 48y. Now when I divide, I get y to be about 25 over 3. Or like 8.3 repeated. Okay, it's okay. It's not going to be a fraction. It's not that big of a deal. And so then, what do I do? So, well, that's all I got to find. That's all. It says which value of y produces the maximum area. So once I did all that stuff, I found the maximum value of y. So 25 over 3, or it's equivalent to about 8.3. 3. We always go 3 decimals, right? Yards. YDS. Okay, that's the value of y. Now you could very easily find the value of x, but it doesn't want you to, so just stop there. Why go further? All right, last one. This one's going to be probably a little more confusing, but hopefully we can understand it. All right, so the position of a particle moving along a straight line, you know, you can read all that stuff. But what I want to do is I want to find the distance that between them that creates a minimum. And so I'm going to say, okay, the distance between them that creates a minimum is equal to S1 minus S2. I'm just going to subtract them, right? So if I subtract them, that gives me the minimum value that is going to be the distance between them. And so I get D is equal to S1 was T cubed plus 2 minus, and then T squared, okay? So again, I'm just going to write that differently, but it's going to be the same thing. And now, because I have my equation in one variable, d and t, I can then take the derivative. So I get d prime is equal to 3t squared minus 2t. That goes to 0, right? And then d prime is going to go to 0, right? And now I want to solve this. So I get 0 is equal to 3t times t minus, I'm sorry, not 3t, hold on, equals t times 3t minus 2. And so then this t right here goes to 0. And then this binomial in here, hopefully you remember how to solve that, it goes to 2/3. And so when t is equal to 2/3, we're in seconds. What are we in? Object of it doesn't say, oh, of a second. Oh, no, that's a second object. I'm going to say we're in seconds. So we'll say we're in seconds. It might not be. I don't know, but say we're in seconds. And so if I wanted to find the actual distance, it doesn't say the actual final distance. It says at what time. So time is 2/3 seconds. But if it asks you to find the distance, then I would plug that into the original formula, right? So I would get d of 2/3. And once I plug that into the original formula, I would get about 1.852 feet or yards or meters, or probably meters in this case. We're dealing with position particle movement, so probably meters. But if you plugged in 0, okay, if you got d of 0, well, that's where the particles really started. So I guess you got to use that 2 to figure out if that actually works or not. But if I plugged in 0, I actually get 2. And so this is actually smaller. So that's actually y. Actually, yeah, okay. So you get 2 answers. Duh, I don't know why I'm doing this. I'm just thinking that 0 is probably not going to be the minimum point because that's where they start off and the things didn't move yet. But we still got to test for it, so I didn't test for it, so maybe we got to make sure we do that. But so once I tested for it, I found that it was 2, and then d of 2/3 was 1.852, so that's obviously smaller, minimum smaller, so that's why we went with that answer. But pretty straightforward, not too bad. And that's it for this section. Have fun in the review for the AP problems. Have fun in the AP classroom review for the chapter test. And then good luck on the exam. It's going to be a doozy. Deuces.